Many years ago, British explorer George Mallory, who was to die on Mount Everest, was asked why he wanted to climb it. He replied, "Because it's there." Well, space is there, and we're going to climb it. And the moon and the planets are there, and new hopes for knowledge and peace are there. John F. Kennedy, September 12, 1962. So for this, I guess we have to talk about space exploration and how we got out there. And I will admit it's not my cup of tea. I'm fascinated by space exploration, just not so much on the ways we get there.
So how about I try to change your mind about this?
Okay.
All right, so now, are you a fan of roller coasters?
Yes.
Traveling on a spaceship is like the ultimate roller coaster trip. Here's your day. It's come up. You're now on the launch pad, strapped into the rocket, and you're headed to space. It's going to be a short trip, but it's going to be an exciting trip. You know, it only takes 8 minutes to get to Earth orbit, but a lot's going to happen in that 8 minutes. So here you are, you're sitting there, you're at the last 10 seconds of countdown, the rocket motors fire, and it starts to lift off the pad. The gravitational pull is enough to hold everything here, but we can escape it if we use rockets that generate enough power for us to travel at about 7 miles per second. So as you're moving faster and faster and faster, it's going to feel like you have something sitting on your chest getting heavier and heavier and heavier. But then once you get to the point of being at the right altitude and the rocket motors cut off, well, the next thing you feel is this immediate release of pressure. And you can feel now that you're weightless.
Right.
And you know when you get to that point that you've reached space. Now you have the freedom to get out of your seat, float around, go to a window and look out and see this remarkable view of Earth down below you, that place where everything we know and love about our lives and our planet and our civilization is all right there in front of you.
On a curved Earth.
On a curved Earth, not a flat one.
That's right.
And you can see it with your own eyes. Almost all of the astronauts talk about that same feeling of observing the Earth from space and what it's done to change their perspective about the planet. And they always say that if we could get every politician into space to look down on the planet, we feel that would change their perspective too.
Definitely. That's what we need to do. So I'd only vote for a candidate now if he goes into space.
I know some candidates I'd like to send on a one-way trip into
One-way
space.
trips, that's true too. Space travel hasn't been going all that long, right? So Sputnik, 1957.
Kind of a short history, yeah. We haven't been at it very long.
Right.
But we've made huge strides. You're right. Sputnik was 1957. Within 10 years, we already had people in space after that. And within 12 years, we actually put people on the moon.
1969.
That's right, sure. And that expanded the human reach out into space. And we could actually go out and explore the surface of the moon and see what another celestial body was like.
One fairly recent expedition I find interesting is New Horizons, because it finally gave us images of Pluto for the first time, this dwarf planet. So left Earth January 2006, got there July of 2015, traveled 9.5 years, almost 4 billion miles, just to fly by Pluto, but we finally know what it looks like now. And I love that it was powered by plutonium. It's so fitting.
Perfect.
As it should be.
What else should it be?
Right? But that was a special moment too. Just finally you get to see the little heart on this dwarf planet.
Look, sometimes my car won't start in the winter. How is it that these spacecraft like New Horizons can travel for 9.5 years, essentially asleep, and then be woken up,
Wow, right?
brought online, and do the job that it has to do?
Right.
amazing.
There's just some really smart people out there.
I think there's some really smart people, some really cool, ingenious methods of figuring out how to make these devices work in these extreme environments. As you pointed out, they really are best for robots to do
to
rather
explore
than humans.
for instead of us right now. I get very irritated by people who are like, defund NASA, and hypocritically, because a lot of objects we use every day is because of NASA and the space program that inadvertently created these objects that we use, but that also includes, satellites. And when NASA started to actually massively get defunded back in the day, they turned their satellites to our own planet, which helped us understand our oceans, our atmosphere. We understand so much of climate change because of it.
I really want my satellite TV, and I want my GPS, and I want all those other things
exactly.
that come out of those programs.
Exactly. So when we talk about future space travel, things just have to move faster. I mean, come on, our closest star neighbor, 4.2 light years away, would take between 80 to 100,000 years.
I don't want to wait that long.
I don't want to wait that long. So there's this project called Starshot, and be a small ass little guy, but with a new type of idea that would allegedly get this little guy to our neighbor in only 20 years.
Well, this is completely different from how we've thought about space travel in the past. And space travel in the past has always seemed to be bigger, bigger, bigger.
Yeah.
And in this case, we're talking about smaller, smaller, like really small. So now we're talking about multiples, like hundreds, I think,
that's right.
postage stamp sized spacecraft. Now, what can we do with a postage sized spacecraft? Well, as it turns out, we can actually put on a chip about the size of a postage stamp many of the components we need to collect data about distant objects, right? So if we can do that, then we have a very, very low mass spacecraft. But how do we provide propulsion? Well, the idea for Starshot is that these tiny little spacecraft have solar sails, and these are big squares of very, very thin material, like a very thin plastic. But what's the wind? Like you'd have on a sailboat? Well, it's proposed that the wind would be powerful lasers that shoot from Earth, and they strike the sail, and the photon pressure of the light pushes the sail along.
Wow.
So what we'd be doing is targeting multiples of these, and as we do this over and over and over again, year after year, these spacecraft then build up the velocity to cover that distance from here to Proxima, 4.2 light years, and as you said, just 20 years.
Wow.
Rather than 80 to 100.
1,000, I know.
I'm sort of in for that.
I'm in for that too.
Yeah.
And I'd imagine they'd have to build multiple because, it's like the greater the number, the greater the chance of getting there, because some will probably die along the way. Let's be real. So from Sputnik to hopefully Starshot, it is quite remarkable how far we've gone. And I will admit, the mechanics once again aren't my cup of tea, but I'm so in awe. This represents the best of humanity to me, the fact that we're capable of it. So I'll leave the mat to the experts, and I'll just enjoy the journey.
And you'd still love to be one of the first out there to see it.
Yes, as long as I get to come back.